Let's talk about what happens when a strike slip fault bends. Now, normally we would have, let's say, two pieces of our fault like this, and I'm going to kind of tilt it up so you can see. And as they were sliding, maybe back and forth, whichever direction, not much happens because they're just sliding by each other. But what will often happen is you actually will get a bend in the fault like this. You can see my sides of the fault there. And I'm going to kind of hold it up like this so you can see it a little easier, but it would be happening like this, of course. And so in this case, now that sliding may not happen. If the sliding goes like this, you'll see a hole actually opens up there. If I were to slide this piece in the opposite direction, you would see that they start to overlap. And so actually you get compression there and everything would kind of get bungled up. I'm going to show you what this looks like. They're called releasing and restraining bends. So let's look at a releasing bend first. That's the first one that I showed you in that little model there. And so let me go ahead and set that up. All right, so this is actually a map view. So we're looking down on the surface there, and we would have this fault that would normally be our regular strike slip fault, but it has this bend in it. And to establish this clearly, let's say that this side of the fault is moving this way, and this side of the fault is moving that way. And so what I can see is that this whole block will be moving down on my board, this whole block up on my board. So if I look at this block and I put lots of little arrows in here indicating that the whole thing is moving this way, and I do the same thing on the other side here, what you'll see is that in some spots it's as we would expect it to be. So let's say right in here, these two arrows are just sliding right by each other, just like that first example with the paper sliding by. Same thing right in here, they're just sliding right by each other. But what we can notice is that if we go to where the bend is right in here, notice those arrows are pointing away from each other. So where that bends there, we're going to have this area pulled apart. It's called a releasing bend. So because it's being pulled apart there, you'll actually get a depression in there. Sometimes that might fill with water. It's called a sag pond. But overall, you're going to be getting an overall depression. If you've learned about other fault types, you would also produce normal faults because you have tensional stress. Those hanging walls are dropping down, producing normal faults, and you're creating like a depression or a basin. So I'll go ahead and write that on the side there as a summary. All right, so tensional stress, creating normal faults, and an overall depression. Now let's go ahead and look at restraining bends, which is just going to be the opposite. All right, so this is the exact opposite, and just note that I'm making the bend really sharp just so that you can see it really easily. Out in nature, they usually don't bend quite like that, but for our purposes here, that makes it really clear. So once again, I'm going to put my big arrows indicating that the block on the right is kind of moving down on the board at least. Block on the left is kind of moving in this direction. I'm going to do lots of little tiny arrows just like we did before, and you can probably even see where this is going. All right, so in the really straightforward areas, just like last time, we get this pure sliding motion here, this pure sliding motion here. But where it starts to get interesting is where that bend occurred. So if I look again right in this bend area, this time the arrows are pointing toward each other. So here, instead of that tensional stress, you're actually going to get compression forming, and that compression is going to pop things up. So it'll pop up mountains if it's a small or a big bend. It'll pop up little hills if it's a small bend. And if we think about the fault types, now we have our hanging wall getting shoved up over. So that would be something like a reverse fault or possibly a thrust fault if it's at a low angle. So I'll go ahead and recap that on the right once again. All right, so now we have compressional stress, we're going to be producing reverse faults, and all of that's going to produce our mountains or our hills. One last little trick that's kind of interesting is to actually use your hands to simulate this. And so if I were to think about this and I had my hands I'm gonna do it like this, and I were to just kind of slide them back and forth and they're nice and straight, I don't produce any kind of stress there really. But now what I'm going to do is I'm going to kind of put a bend in my hand, right here actually. I'm gonna bend it like this. And now when I try to move my right hand to the right and my left hand to the left, I get this compression forming at that bend. If I do the opposite, I open up this hole. So very similar to what the paper is doing, you can do that with your hands and try it at home.